Hello, in this video we're going to solve the systems of equations using the graphing technique. Now, graphing technique is the first technique we've learned, and it's great, but it's really important to remember that this technique very quickly becomes not as useful when trying to find an exact answer because of the fact that your graphs could be very big, the answer might not be very nice, and what I mean by nice is that it's easy to read off the graph, i.e. it's an integer point, so say 1, 4. But it really highlights that idea that when you solve the systems of equations, you're finding the point of intersection. So to do this, a nice way we can always graph a linear equation is to rewrite it into y equals mx plus b form. So if I put 2x plus y equals 4, and that's my first equation, I can rearrange this to y equals negative 2x plus 4. And that tells me two important pieces of information. The first one is the slope, which is negative 2. And we could say this negative 2 over 1, so we go down 2 and over 1 each step. We know the y-intercept is 4. So when we have this information, this line becomes very easy to graph. What I do is I just put a point at 4, and then I go down 2, 1, 2, over 1. 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 And then I just have to get my ruler out and connect the dots. Now it's really important when you graph this that you use the entire page and put arrows on the end to indicate this goes on forever. So now we'll just switch colors. And switching colors here helps me keep track of things. And we'll do the same thing for the other equation. We have 3y is equal to 2x minus 12. Then we're going to divide each term by 3. So y is equal to 2 over 3x minus 4. So therefore, the slope is 2 over 3. So for every 2 up, I go 3 across. And the y-intercept is negative 4. So all I do is I take my pen, I put a mark at negative 4, the y-intercept, and I go 1, 2 up, 1, 2, 3. And right away, there is my point of intersection. And we're done. Now, I really want to highlight that these questions are picked very specifically such that they work nicely. In real life, they don't always work nicely. In fact, very rarely do they. So this graphing technique, though important to use or to understand so that you know what you're finding, usually we want to use our process of substitution or elimination. I hope this video helped.